Aquatic ecosystems are vast. I tend to work mainly in the ocean, but I've done some work in freshwater, and what I'm going to say really applies to both. So the ocean ecosystem is the last place on Earth where we still harvest wild animals. That doesn't happen on land. And so that makes it a very unique problem, but we don't see these animals. And so we need to decide how many we're going to take. We need to allocate who's going to take them. And so we need to manage those fisheries. That's a very difficult task. And we use models based on population dynamics, which are births and deaths at the population level, to try and model those populations and figure out how to harvest them sustainably. So my role, there have been a couple of things that I think I've added a little bit to that. One is to remember that fish are individuals, and that what happens at the individual level, at the small scale, is really important. So things such as predator-prey interactions, competition among juvenile fishes in small spaces eventually multiplies to the population. So incorporating behavior and individual-based ecology into these population dynamics models, I think can be very important. And in some ways, the consideration of multiple species has led to what we call ecosystem-based management, where we consider not only the target species that we're after, but everything else that surrounds that species, what it eats, what eats it, the nature of the water that it lives in, and of course, the humans and their impact. Secondly, my other contribution is fundamental because it's a way to think about fish populations by only looking at their size. Size turns out to be a really important trait in fish species. And so you can simplify many of these models by just considering how large they are. And that will help you explain much of the ecology of these species. And so that's been a major contribution, I think, as well through my career.